Welcome to Section 8.1, Part 3. This is the 63rd session of the CISSP exam prep series. This part finishes our set of secure design principles. In this session, we'll rethink where trust lives in a modern network. We'll answer several questions. What is zero trust? And why did the old perimeter fail? How does microsegmentation contain a breach? When is total isolation the right call? How does trust but verify compare? And which one wins today? What is privacy by design? And what problem does Secure Access Service Edge solve? Why does this matter beyond the exam? Because the old idea of a hard shell around a soft interior no longer fits reality. Picture a laptop that works inside the office, then at a coffee shop, then back at a client site, all in one day. There is no clean inside or outside anymore. As an architect, you are the one deciding how to secure identities and data when the perimeter has effectively dissolved. These principles are how you do that. So what is zero trust? And why did the old perimeter fail? Zero trust means nothing, and no one is trusted automatically, inside or out. The old model assumed everything inside the network was safe, which crumbled the moment an insider went rogue or an attacker slipped past the edge and roamed freely. With mobile devices and cloud services, the line between inside and outside barely exists. Zero trust flips the assumption to never trust, always verify, and it assumes a breach has already happened. Every single request must be authenticated, authorized, and encrypted before access is granted. Think of an office where your badge is checked at every single door, not just the front lobby. How does microsegmentation contain a breach? It slices the internal network into many small, walled-off zones. Each zone is separated by internal firewalls, subnets, or virtual LANs. And a zone can be as small as one high-value server. Traffic between zones is filtered, often forced to authenticate, and usually encrypted. The payoff is that a breach in one zone cannot spread sideways across the whole environment. This is what stops lateral movement. So an intruder who lands in one corner stays stuck there. Picture a ship built with watertight compartments. One flooded room does not sink the vessel. When is total isolation the right call? Sometimes filtering is not enough, and you need to cut a system off completely. That is an air gap, where a machine has no wired and no wireless link to any other system. It physically severs the network path. Because wireless signals are everywhere, enforcing a real air gap can even require shielding, like a Faraday cage, to block stray radio. Think of a sealed vault with no doors, windows, or phone lines. You reserve this for the most sensitive systems, because the isolation that protects them also makes them hard to use. How does trust but verify compare, and which one wins today? Trust but verify is the older approach, where anyone inside the security perimeter is trusted after an initial login, then largely left alone. The problem is obvious. That standing trust is exactly what lets insiders abuse access and lets intruders move laterally once they are in. Given how fast threats evolve, a single check at the door no longer holds. So when the exam asks zero trust or trust but verify, the modern answer is zero trust. Continuous verification beats a one-time handshake. What is privacy by design? It is the practice of building privacy protections into a product from the very start, rather than tacking them on at the end. It mirrors security by design, treating privacy as a core part of the architecture across the whole software development lifecycle. Its foundational principles push you to be proactive, not reactive, to make privacy the default setting, and to protect data across its entire lifecycle with real transparency and respect for the user. The whole point is prevention. Stop the privacy violation before it can happen. Think of designing a house with curtains already fitted on every window, instead of scrambling for cover after the neighbors complain. What problem does Secure Access Service Edge solve? It answers the reality of a cloud-based, work-from-anywhere world. Secure Access Service Edge, often shortened to SASE, merges network security functions with wide-area networking into one cloud-delivered service. Instead of hauling all traffic back to a central office, it pushes security and networking out to the edge, close to users, which cuts latency. Its core is identity-centric. It leans on zero-trust network access, so every user and device must authenticate and be authorized, with multi-factor authentication for users wherever possible. It also monitors behavior continuously and adapts in real time. Think of a security guard who travels with you rather than sitting at one fixed gate you must always drive back to. So let's bring it together. Zero Trust throws out the safe inside assumption and verifies every request, every time. Microsegmentation walls the network into zones to stop lateral movement, and an air gap goes further with total isolation. Trust but verify is the outdated model, and today the answer is Zero Trust. Privacy by design bakes protection in from the start, and Secure Access Service Edge delivers Zero Trust security from the cloud, right at the edge. Together, these move trust from the network boundary to the identity itself. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.